Chapter 6 deals with energy. And when we talk about energy, one of the first concepts that we deal in is work. And the reason we deal with work is because work is essentially a change in energy system. Okay, so by definition, work is the change in the energy system resulting from the application of a force acting over a distance. Okay, so that by definition is work. Okay, I use W for work. Okay, it's got units. The units is what we call a J for joule. Joule. J for joule. Okay, so I'll use a capital J. Okay, uh, for those units of work. That's also happens to be the units for energy, and I'll use capital E for energy. Uh, so as you read this definition, uh, seems to be a little wordy, uh, and as most science definitions, it's not great for uh, you know it's not always easy to understand. But we can understand it pretty good if we start looking at it equation-wise. At least I can as a mathematical person. I like to put things into equations. So let's put this definition into an equation form. Okay, what is work? Well, work is equal to change in energy. That's one equation. Work equals change in energy. Okay, change in energy. So that's energy final minus energy initial. Okay, that's the first equation, the first thing that work is. And we're going to come back to this. Okay, we will come back to this, but so this isn't the first equation or only equation that deals with work, and we will come back to that. But there's this other equation that work is equal to, and taking off of this second half of the definition is that it's an application of force acting over a distance. So work is also equal to a force times a distance, F times D. D for distance. Some people will use L for distance. Uh, so you might see it like this, and in fact, I believe your book uses L for distance. There's also times that I'll use the displacement notation for work. So you could see it in this format. Work equals force times displacement. I use delta x for displacement, change in position. So any number of you may encounter any number of these equations. They're all the same equation. That's just how a difference in how you denote distance. And if we're working with straight lines, which we are doing all the time in here, or most of the time in here, then displacement is equal to distance. So it's not really a huge deal. It's just a matter of preference. I'll often prefer in my class to use this equation. Uh, Schwab's class may use this equation, or this one. Actually, likely this equation, the force times L for distance. So, as we do, now we know the equations, let's talk a little bit about examples of what is and what isn't work. Some of the things that and why they are or why they are not examples of work. One thing is pushing a shopping cart at a constant velocity. You're doing work because you're applying a force, you're pushing, and you're moving the cart a distance, okay, or a displacement. uh, you're pulling a wagon. Well, you're pulling it. That's a force. And if you're pulling a wagon, and we're assuming that the wagon is moving. If it's moving, so let's say we're pulling a wagon down the street would probably be a better way to word it. Down the street, because you can pull a wagon and not move it, uh, and that would, if you pulled a wagon and you didn't move it, that would move over here to the non-examples, which we'll talk about. Lifting weights off the floor. If you lift weights uh, from the floor and lift them over your head, say, that's an example of work because you're applying a force. There's force interaction and there's a distance that the weights are moving. Non-examples, hitting a locker. Assuming that the locker doesn't dent, if you hit a locker, generally it doesn't move. Well, if it doesn't move, if it doesn't have a distance or if it doesn't displace, then you have no work is done. There's no distance. Distance is zero, so there's zero work. Same thing, pushing a heavy object that doesn't move. It's not moving, there's no work. Trying to pull a tree stump out of the ground without success. If you're not successful, that means it's not moving. It's zero work, okay? It may seem like you're doing work because you're getting tired as you're pulling the tree stump out or trying to pull the tree stump out, but that doesn't mean you're doing work, okay? So work is a little different than, the definition that you're used to thinking of with work. Okay, so we got to eliminate that from our brain a little bit and think about what work actually is. It's a force times a distance or a displacement. If you haven't displaced, there is no distance, there is no work.